In this example, Sarah left home at 10 and cycled north in a straight line. The diagram shows a displacement time graph for her journey. Part A, work out Sarah's velocity between 10 and 11. And on her return journey, Sarah continued past her home before returning. So first we look at the displacement. So we say displacement, it will be equal to 1.2, and so in this scenario it will be actually the displacement in this scenario 12 kilometers, and the time it will be 1 hour. So for us to find the velocity, it will be distance over time, so that would be 12 over 1, and that will give us 12 kilometers per hour. Now, in terms of finding estimate time that Sarah passed her home, so we look at that by looking at the time. So we're estimating this to be at approximately this point. So we say Sarah passed her home, and the reason why, because it's crossing the x-axis, because we assume she started from, because we know she started from her home, which is 0 point, so that means we need to cross the axis, which will be the point where she returned home. So that will tell us that passed her home at 12:45. So this will be our answer for part B. For part C, we need to work out Sarah's velocity for each of the last 2 stages of her journey. So in this scenario, we see for distance for the latter parts, it will be starting from the top, which is starting from the 12 going down. So we say displacement, so we call this range displacement 1, so which will be minus 12 kilometers, and also taking minus 3. So in this scenario we would have minus 12 plus also another minus 3, so that would give us minus 15 in terms of the displacement. And the time, as we are for this is the first part, and this is the second part, second displacement, so that will give us the addition of these two, which are negative journey, minus 15 in this scenario, and the time will be for the scenario 1.5 hours. Now, to find the velocity, we say v equal distance over time, so that will be minus 15 over 1.5, so that will give us approximately minus 10 kilometers per hour. Now, for the final stage, we say that it is also, it goes up. So this is stage 1. Now stage 2, we would have displacement being equal to 3 kilometers as it goes up. So that's stage 2. In this scenario, we would have displacement equal 3 kilometers and the time to be equivalent to 1 hour. So the velocity will be 3 over 1, and that will give us 3 kilometers per hour. And this will be our answer for part C. For part D, we need to calculate Sarah's average speed for her entire journey. So for us to do that, we will add the entire distance. So that will be distance total will equal 30 kilometers, and the time total will be equivalent to 4 hours. So in this scenario, velocity will be distance over time, so that will be 30 over 4, so that would give us 7.5 kilometers per hour, and this will be our answer for this question. In this example, a ball is thrown vertically up in the air and falls to the ground. This is a displacement time graph for the motion of the ball. For part A, find the maximum height of the ball and the time at which it reaches that height. So for us to find the answer, so reading from the graph, we can see that it reaches so you can say reading from the graph, you can see that height equal 2.5 meters. So this is the point here, and we also can see the time taken to get there. So we also almost drag a point across the time. So we say time will equal approximately 0.75 second. So this will be our answer for part A. For part B, we need to write down the velocity of the ball when it reaches its highest point. So in this scenario, we know the distance and the height and the time, so v which is also equivalent to distance. Now, so that will tell us now for us for the point where it reaches when it reaches could just explain that when it reaches the highest point, the velocity of the ball is 0 meters per second. Okay, so this will be our answer for part B. For part C, we need to describe the motion of the ball if I from the time it is thrown to the time it reaches its highest point. So for part C, for part I, we say the velocity of the ball, velocity of the ball is positive upward, and decreases, so the ball is decelerating until it reaches 0 at the highest point. So this will be our explanation for part I, that the velocity of the ball is positive when it moves upward, and then it decelerates and decreases until it reaches the 0 at the highest point. Now for part C double I, we also need to explain that after reaching what happens after reaching its highest point. So we can say that again the velocity of the ball is negative downward, and increases, the ball is accelerating until it reaches the ground at the same speed at which it was launch. So in the second cigar, after reaching its highest points, the velocity actually travels downwards. So the velocity will decrease, and then also the movement of or the acceleration increases because it's moving downward until it hits the ground, and at the same because of the speed, it will continue similar to the speed that it was launched at. And this will be our answer for part II and also our explanations for this question. In this example, the figure shows the velocity time graph illustrating the motion of a cyclist moving along a straight road for a period of 12 seconds. For the first 8 seconds, she moves at a constant speed of 6 meters per second. She then decelerates a further 4 seconds. For part A, we need to find the displacement from the starting point of the. So if we look at the graph of the area under the displacement for 12 seconds, it would be represented by the area of a trapezium, which here half would be A plus 12 and multiplied by 6. So in this scenario, we would have approximately 60 meters in 12 seconds. So this will be our answer for part A. For part B, we need to work out the rate at which the cyclist to find the acceleration is the gradient of the slope. So for us to find 1.5, which represents squared, and this will be our answer for this question. In this example, a particle moves along a straight line. The particle then travels at a constant velocity of 8 meters per second for 5t. The particle then decelerates in a further 40 seconds. For part A, sketch a velocity time graph to illustrate the motion meters. So for part A, we will create velocity. So in this velocity, and then we will decelerate. So the distance is acceleration, and the final is represent, and this will be our representation. For part B, we need to find the value of t. We can take the area. We have the area, the displaced total is meters, and the area a trapezium half, and here we have half h equal. We'll sub the values into it, so we have 5t. Now to simplify this expression, we would have on the left hand side, we would have in this scenario 4t equal 40, 600. So for t, we would have 160 of the 4, multiply the whole expression by 4, 60 all divided by 44. So the value of t for the scenario, which will be represented, and this will be our answer. The diagram shows the velocity time graph of the motion of an athlete running along a straight track. For the first 4 seconds, he accelerates uniformly in the diagram. This velocity is then maintained for a first constant. For part A, the rate at which the athlete accelerates. So in scenario, the velocity that we have is 9 and that is 4. So that will give us a square. So this will be our answer for. Now for part B, we are asked to find the displacement from the starting point of the athlete after 12 seconds. So for us to find that, we can see that the velocity time graph represents the displacement. So we can say S can be represented in the area of the trapezium, which will be half multiplied A plus. So the whole region under, so this region represents A, and this represents B, and this is the H. So we would have S equal 12 meters. Say this is at time 12 seconds, and this will be our answer